A common claim that all flat earthers make is one involving aircraft flying over the globe. Well, instead of me explaining that claim, why don't we hear it from the horse's mouth? This is from one flat earther, Glenn Hall.
You see the globe, now consider an airplane. Okay, this airplane is going to fly always at a level altitude with respect to the Earth. And any of you who have studied the flat Earth ideas know that there is an equation that describes how much curvature is in the Earth from given distances, and that is defined as 8 inches times the number of miles squared. So that if you go through that calculation, you can figure out how far below the horizon something should be from a particular distance. And the idea also is that as a plane would traverse the globe, it would have to be always adjusting its nose a little bit down in order to continue at a level altitude.
This claim now expands to also include statements like, the FAA assumes a flat Earth when training pilots using their target generation facility. I do have a love for flight and flight simulators. If you look in my channel, you will even find link to my sim channel. So this claim hits a bit closer to home for me. How about while we are debunking this claim, we also have a quick crash course on flight instruments. Is it necessary? Well, not really, it's fun, and some of the instruments would help explaining what really happens. Let's look at this lovely image from learntofly.ca. It's a Cessna 172 instrument panel with a lovely box showing the most important data panels. Now 3 of these instruments are connected to aircraft's pitted static pressure system, and the other 3 are gyro, typically connected to aircraft's vacuum system pumps. The pitted static system relies on a pitted tube to measure the dynamic pressure due to the forward motion of the airplane through the air, and the static vents to measure the static outside barometric pressure as the airplane gains or loses altitude. Then we use gyroscopic precision, which is the tendency of a rotating body to constantly react to a force being applied by turning in the direction of its rotation exactly 90 degrees to its axis. And these principles are used to measure attitude, heading, and turn. Panel number 1 is airspeed indicator and is pitted static. Funny thing is, this is not the speed of aircraft moving through air, but really the speed of air flowing over the aircraft. This is not a measurement of ground speed and usually calibrated in nautical miles, known as knots. Panel 2 is attitude indicator, also known as the artificial or gyro horizon. This flight instrument depicts the position of the airplane in relation to the horizon. Panel 3 is altimeter. This we need to know about. This measures the height of the aircraft above sea level. The altimeter reading is based on barometric pressure, and that pressure is constantly changing. This requires the altimeter to be set prior to every flight and during flight as barometric pressure in your flying area changes. Panel 4 is VSI or vertical speed indicator. This also uses barometric pressure to measure this value. At a glance, VSI shows if we are flying at steady altitude or if we are ascending or descending. Panel 5 is heading indicator. This is not a magnetic compass, but instead is based on gyro and must be set according to the magnetic compass indication before takeoff and occasionally adjusted to the magnetic compass while the aircraft is in steady level flight. Finally, panel 6, turn coordinator, another gyroscopic instrument giving information on direction and rate of turn. Now, the fun part. Once you're airborne and steady, it becomes a dance between throttle and pitch. Typically, you'd set to throttle at around 75% and then correct the pitch to keep the plane leveled. Now, instead of constantly pulling back or pushing forward with the yoke, you use the pitch trim knob. It simply sets that pull-push offset so you can leave the yoke at neutral position. Now, an aircraft uses lift from its wing, which depends on aircraft speed and air density. As higher you climb, oxygen concentration gets lower and you get less thrust. Also, the air density reduces, which means less lift. Which means, at some point, this lift would not be enough to counteract with its weight, and the aircraft cannot go any higher. And because the wings must maintain the same angle to the relative wind to generate the lift needed to stay at that altitude, the nose has to be corrected. In a Cessna, that's all you. Throughout the whole flight, you need to keep tweaking the trim. On computer-assisted system, this nose will be corrected automatically. So we know there is a correction. But what kind of correction are we talking about here? Well, suppose an aircraft traveled 1/4 around the world. So the nose dip would be 90 degrees. And the distance is, well, Earth's circumference is 21,639 nautical miles. So about 5,409 nautical miles. It means we need to adjust it by 1 degree over 60.1 nautical miles. On our trusty Cessna 172, at optimal cruise speed, that would take around 30 minutes. Even a long-distance commercial passenger aircraft typically cruises at maximum 500 knots, which means it would take over 7.2 minutes for this 1 degree change. This is imperceivable to naked eye. Suppose you didn't adjust anything. Well, then you'd either be climbing or descending. Now, if you're climbing, at one point you reach that place where lift is less than weight, and you stop climbing. Thus, it will never be able to fly off the Earth. World is huge. I mean really, really huge. And this is what these flat earthers don't seem to understand. This 8 inches per mile squared. Well, an YouTuber Hit did a really nice video on it, and link would be in description. Simply put, they got this number from Samuel Birley Rowbotham's Zetetic Astronomy, and presumably he got this from Encyclopedia Brittanica. The problem is, this equation is in context of civil engineering and not mathematics. It is just an estimate for plane surveyors to compensate for the drop in a target, and it builds up inaccuracy as the distance increases. I have linked a website in description that shows you the calculation and how at 391 km is most accurate, and the error margin increases over distance. But instead of reading all that, why don't we do a simple calculation ourselves? This time, we don't need to use nautical miles. Earth's circumference is 40,075 km. And though it's not an exact sphere, but a spherical object, for example, let's suppose it's a perfect sphere. So a quarter of it would be a bit over 10,000 km. The drop here is obviously the radius of Earth, which is 6,378 km at the equator. But if we use the 8 inches per mile squared equation, okay, 10,000 km is around 6,213 miles. So that squared becomes a large number, a bit over 38 million. Time it by 8 brings us over 308 million inches. 1 inch is 0.0254 meter, so that 308 million inches become over 7 million meters, or about 7,843 km. That is a discrepancy of over 1,465 km, or a 22% error margin. But flat earthers would often use this equation with various pictures and claiming such and such things should not be seen if there were a curvature. It is also used in this flyer. If we plug in that 500 miles per hour value into that 8 inches equation, we get 2,777 feet value. We also don't measure the change in degrees and not in drop. Drop is a loss of altitude and definitely not a good thing. Put simply, suppose you tie a nut to the end of a string and spin it around. If you are spinning it fast enough, the distance between the nut and where you're holding it would be roughly the same. Would you say that it dropped by whatever distance? Of course not. The only measurement is how fast it's traveling in degrees. When an aircraft goes around the globe, the distance to sea level is also roughly the same and should be measured in degrees. Next, I don't see any point of contacting FAA. As I know, we have to adjust the nose. I also understand the physics used in 1980s flight simulator is not the same physics we use today. If I'm writing a very simple simulator, I might use a flat plane, but that doesn't mean the Earth is flat.
So you start your journey at the Arctic, as far to the north as you can. And you begin to go south. Now notice, as I'm going south, I have to continue dipping the nose of my airplane in order to stay level with the ground. Now I'm going to continue all the way to Antarctica. Now notice, I'm continuing to dip my nose down to stay level with the Earth. Now I'm going down into South America, continuing to dip down, and finally I get down here to Antarctica. And look at that. My airplane is upside down.
Finally, this just cracks me up. One of the coolest things I saw was a globe where south was up instead of the traditional north. That was just to indicate that there is no up or down. In ancient Chinese maps, the emperor who lived in the north of the country was always put at the top of the map, with everyone else, his loyal subjects, looking up towards him. Many early Arab and Egyptian cartographers placed south at the top of the map because, having most of the world they knew off to the north of them, it drew the most attention to their area. And the same applied to Europe. Being a powerhouse producing both heavy exploration and the printing press, it was instinctual for European mapmakers to put Europe at the northern hemisphere as the focus at the top of the maps. Mercator's world map from 1569 was almost certainly a defining moment in a north-up mapmaking. His map was famously the first to take into account the curvature of the Earth, so the sailors could cross long distances without overshooting the mark. Whatever the reason, north up is an idea that seems to have stuck. A famous NASA image from 1973 was actually taken with south at the top because the astronaut who took it was spinning around at that time. NASA decided to flip it over to avoid confusing people. So there is no up or down. It all depends where you're looking from. Well, that's all for this video. Thank you for watching. If you have enjoyed it, can I please ask you to leave a like and maybe comment as well to feed the YouTube algorithm? If you can also subscribe to be notified of new videos, it would definitely help this channel grow and would be thoroughly appreciated. Have a safe day. Signing off.